Fractional equation modeling, or SEM, is our video for today. We have four libraries: the tiDevice, the dplayer, the Novan for the SEM, the semi-plot that we are going to use. We're going to read through the data. It's a big data that we have. We can just have a view of the data. And this data is Likert scale data, which has approximately 100 columns. We're not going to use all of it. And it has 116 entries. So it's not a very big data as such. So that's the data that we want to work with. Now, what do we want to do? We want to see how we can fit a model. And this data, if I look at a few things about it, if I look at the structure of data one that I'm calling data one, we can see most of it is a character. And that's what we plan to change from that data. So what I'm going to do, I'm going to change the columns from character to factor. That is on this part here. And the purpose of that is because it's a Likert scale data. I would want to reformat it so that I can clean it up. I'm going to remove this, and I'm going to, because now I've created it as a factor, I want to use numbers to record my data so that I'll get something similar to that. And that's what I'm doing at this point in time. I'm using mutate art from column 1 to 93, or this, starting with 1, strongly disagree strongly to agree strongly at 7. So I'll run that data, and now I get to a point where I want to create a set of variables so that I come up with a model. I have the employee empowerment. I already know which columns represent employee empowerment. So I take column 26, column 210, the other columns are here. And then I'm going to create my own variables that I'm going to use. So some of the columns are here, 26, 210, among many others. And the first variable I want to create is employee empowerment. So I take my data record, which is this. I select the columns that I'm interested in and I get the mean value. So it's going to get an average value for all those columns. So that's what I did for that. And then family welfare, I knew the columns. I had two columns. I got the mean value, the TW, that is the teamwork, involvement, trust, social behavior, collaboration, and all that. I combine them together, those 7 variables that I've created, and I get my data 2, that I've created by getting the average value. So I've created the data that I need, and now once I have my data, I can now go to the SEM model. And in the SEM, I want to look at HR. HR is made up of EE, W, and TW, and then the social behavior or the social capital is made up of IT, TC, SB, and CB. And therefore, with those two, then I see how social capital is influenced by the human resources. So that's how I develop my SEM model. I say I create the name of the model, then I put this and that, and then I want to see the variable in the regression model. So that's the process I would go. If you already have the data, this is how you can create your model, and then you get your structural equation model. And for me to know if a model is a good fit, there are some things to check out. One of them is the SRMR should be less than 0.08, FCI should be greater than 0.95, RMSEA should be less than 0.08. I have the root mean square error of approximation and standardized root mean square residual. So now the next step, remember I have my model here, SCH underscore HR. I have my data too. I come and put them in SEM. I take my model and the data, and I want the mean structure to be true. So I'm fitting the data. So I fit the model, and I can get the summary of the model, the fit measures, the R square, and the confidence intervals. And if I look at that, first of all, you can see my R square values for each one of the variables, even including the new variable, the social capital that I've developed in the model. And we can get the variances for each one of the variables, the intercepts for each one of the variables. I can look at the relationship between social capital and HR with a constant A. The estimate is 0.73. So you interpret this result just like the way you would interpret any linear regression model, that 1 unit increase in the HR will lead to 0.743 units in increase in social capital among the employees. So HR has a lot of influence on the social capital in an organization. Same case here, you have your variables. We created our HR with these three variables and SC with these three. One of them becomes a fixed, the EE, as you estimate the others and you check their significance. So this is all the reports you can give. Now we have other values that we want to look at, and that's what we want to see, the fitted measures, and these are the values we are interested in. We say that the condition is that RMSEA should be less than 0.08. We can see it's true. CFI is more than 0.95, ours is 1, and SRMR is less than 0.08, this is 0.033. That shows that our model is a good fit. So that's the process. And now I can even do a simple plot, and that gives us the graph that you would have wanted to have a look at. So this is how the graph would look like, and how the variables are related. So this is how you would fit in a structural equation model when you have the data using the R software. Thank you so much for watching.